Welcome Statistics 1 students to week 15 of our maintenance. Hope you are all doing well. We are looking at a whole bunch of different exam questions on the KIs that we've been studying at school. So this should be mainly revision and practice for you. The first question today is a representation of data question. I've got a typing test that's taken by 111 people, that's our total. And the number of typing errors they make in the test are summarised in the table below. We've got some frequencies there, and we've got to draw a histogram. So probably what I'm going to do is I'm going to write the class width up here, and you can see that this class width goes from 1 to 5, but what we would do there, the boundaries is 0.5 to 5.5, so you can actually see that the class width is 5. The boundary here is 5.5 to 20.5, so that is a class width of 15. The next boundary is from 21 to 35, so it's actually from 20.5 to 35.5, and so that's also a boundary, class width of 15. The next one is from 35.5 to 60.5, and that's a distance of, or class width of 25, and the last one is from 60.5 to 80.5, so that's just class width of 20. And now we're going to work out our frequency densities. Now remember that frequency density is equal to the frequency over your class width. So if I want to get this first one here, I'm going to go 24 divided by 5. So that's giving me 4.8. For the next one, I'm going to go 9 divided by 15, which gives me 0.6. Then I'm going to go 21 divided by 15, which gives me 1.4. 15 divided by 25 gives me 0.6. And lastly, 42 divided by 20 gives me 2.1. So I'm now ready to draw my histogram for this. So I will go up here in frequency density 1, 2, 3, 4, 5. So we'll label this as frequency density. And then on the horizontal axis is our number of errors. Now, the way I would label this is I'm going to go and have my class, I'll just go 10.5, 20.5, 30.5. Remember, this will just be a sketch when you're doing it. 40.5, 50.5, 60.5, 70.5, and then 80.5. Now I'm doing that because remember the class boundaries that we talked about before, and I guess we can say this is number of errors. Okay, so the first one is 1 to 5, so it's approximately going to be in here somewhere, and we've got a very skinny bar, and that's going to be up to 4.8. So we drop that bar down. Now it's it is a little bit tricky for me to draw this accurately. I could try a line, but I always have trouble with just getting it accurately. Yeah, it's not good at all. It needs to go over a little bit, maybe just a bit. But yeah, then it goes too much. You'll have to just take the general idea here, team. Okay, so that should be at 5. It's not quite. Now the next one has a frequency density of 0.6, and it finishes at 20.5. So 0.6 would be here. Now this is a bit easier, this one. So we've got a thicker bar there. Maybe I'll just make this a bit wider for now. Okay, and that goes down there. The next one goes from 20.5 to 35.5, and we've got 1.4 there. So 35.5 is about here, 1.4 is about there-ish. So it goes like that, and down there. Okay, oh dear, oh dear. You get the general idea though. The next one is from 30, goes to 60.5, and that's only 0.6, so we're back down here again. So that's that one. And then the final one is 2.1, and that goes to 80.5. So 2.1 would be up here, all the way there, down here, and I'm thinking that's not too bad. Okay, moving right along. We want to calculate an estimate of the mean. So what I'd probably do for this is I might grab this table here, and I'll bring it down here, because if we're going to estimate the mean, we think about our mid interval values. So mid interval value of 3, 13, 28, so you add the two together and divide by 2, the ends of the boundaries, 48 and 70.5. And so the fx values will be 3 times 24, so that's 72. Then 13 times 9, which is 117. And then 28 times 21, which has given me 588. And then 15 times 48, which is 720. And lastly, but not leastly, 42 times 70.5, which is giving me 2961. Now, the estimate of the mean is sum of fx over the sum of f. So sum of fx, we add all of those fx values together. So 72 plus 117 plus 588 plus 720 plus 2961. My kids are having either an argument or someone's hurt themselves in the background. I apologize for the noise. 4458, and this is going to be over a total of 111 people. And when I do that divided by 111, I'm getting 40.2. Okay, and then I've got to state the range, the class that contains the lowest quartile. So the lowest quartile, if we go 111 times 0.25, this will give us a value of 27.75. So the 28th value is our lower quartile. So 28th value is clearly in this boundary here, because 24 plus 9 is going to be 33, so it's from 25 to 33 there. And then if we want to find the upper quartile would be from 111 times 0 times 75, and this gives us 83.25, so we end up with the 84th item. Now the 84th value, if you count here, it's going to end up in this range here. So if you go 24 plus 9 plus 21 plus 15, that only takes you to 69. So the 84th must be in that last bracket there. Now, we're trying to get the lowest value of the interquartile range. So you take the lowest value of the upper quartile and take away the highest value of the lower quartile to get the smallest possible interquartile range, which is 41. Alright, so the probability question, we've got some playground equipment, swings, roundabouts, climbing frames, and playhouses. Very exciting. The number of pieces of equipment is listed. The different playgrounds, we've got playground X, Y, and Z. Each day, Nura takes her child to the playgrounds. Probably she chooses playground X is 1/4, Y is 1/4, and Z is 1/2. And she arrives at the playground. She chooses one piece, of equipment at random. We've got to find the probability she chooses a playhouse. Well, how do we get playhouse? Well, first of all, the equipment. How many pieces of equipment have we got in each playground? So playground X, we've got 9 pieces. Playground Y is 12 pieces. 12, and we've got 16 pieces in playground Z. So choosing a playhouse, well, if she goes to playground X, that's 1/4 chance, and then out of that there's a 4/9 chance of a playhouse. 1/4 chance of choosing playground Y, and then that's a 2 out of 12 chance of getting a playhouse. There's a 1/2 chance of choosing playground Z, and there's only one playground. No, wait, what are we doing? Playgrounds? Playhouse, yeah, one playhouse amongst 16 options there. Now, when we pop this into the calculator and try it all out, what are we getting? I'm getting 53/288. Given that Nur chooses the climbing frame, find the probability that she chose playground Y. Okay, so probability of Y given climbing frame. Now, another way of writing this is the probability of Y intersection C over the probability, that's a P, it's a very messy P, of C. Now, the probability of Y and C, or intersection Y, C, is 1/4 chance multiplied by C is 1/12, isn't it, in Y, over, now we've got to add up all of the chances of getting C. Well, you can't get C in X, so that's 0, and then you've got the 1/4 times 1/12, which is playground Y, and then playground Z is 1/2 a chance to get it, and then the climbing frames are 4/16. My 4s always go a bit funny on this. 4/16. Okay, and if we plug that in to the calculator, what do we get? I'm getting 1/7. Now, moving along to discrete random variables. A book club sends 6 paperbacks and 2 hardback books to Mrs. Hunt. She chooses 4 of these books to take at random to take on her holiday. The random variable X represents the number of paperback books she chooses. Okay. Show the probability that she chooses exactly 2 paperback books, and that is 3/14. Okay. Well, if she chooses exactly 2, you get 6/8 times, then there'd be 5, the next one she chooses, 5/7, and then the other 2 must be 2 over 6, because that's a hardback, and then 1 over 5. Now, you can think about the different ways that she could do this. So, you could go paperback, paperback, hardback, hardback, which is what we've done. So you see there's 4 items, so we can go 4 factorial, but then we've got to divide it by 2 factorial, because there's double up P, double up H. So altogether, that gives me, what does that give me? 4 factorial divided by 4 is 6. So this is 6. There's 6 different ways of organizing these. So I'm going to multiply that by 6. And this gives me, when I multiply it out, what do I get? That should be 3/14, and it is. Now I've got to draw a probability distribution table for X. So X could equal, let's see, what are the options? How many paperbacks? The fewest number of paperbacks I could get is 2, because there's only 2 hardbacks. I could get 3, or at most I could get 4. Now I've got to find the probability that X is equal to X. Now, we've already done this one, 3/14. Now, how do we get 3 paperbacks? Well, 3 would be 6/8 times 5/7 times, and then the next one, 4 out of 6, and then the last one would be 2/5. And how many ways can you rearrange that? Well, there's obviously 4 different ways you could rearrange that. So I've got paperback, 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 hardback, but you can see that H could swap into 4 different positions. So when we do that one, I'm getting 4/7 for that. Then last of all, if we go for 4, there's only one way we can do that, and we've got to get every one a paperback. So 6/8 times 5/7 times 4/6 times 3/5. And when I do that, I'm getting 3/14 for this. Okay. Now the next question is I've got to find var x. Okay, so I know that ex is equal to 3, expected value is 3. So remember, var x is defined like this. It's equal to e x squared minus ex squared. So we would go 2 squared times 3/14 plus 3 squared times 4/7 plus 4 squared times 3/14. Take away the expected value squared. Now the expected value we said is 3 in the question. Take away 3 squared. Now what does this give us? When I pop this into the calculator, I'm getting 3/7 as my final answer there. Now we're moving on to our favourite, permutations and combinations. Now we are trying to find all the ways the 8 letters, so that's handy, 8 letters of Tanzania can be arranged so that all the A's are together. Okay, if we take Tanzania, you can see there are 3 A's, 1, 2, 3, and then you've got 1, 2, 3, 4, 5 that you've got to arrange, and you can treat this as one whole thing. However, we also have, let's have a look, we've got double ups. So we've got an N and another N, and of course the A. So we've got A, and A, and the rest are not double ups. Okay, so you can see here we've got 1, 2, 3, 4, 5, 6 things that we're arranging. We can then say we've got to take into account the 2 N's, which could take any, they are exactly the same, so we're going to divide by 2 factorial there. Now, 6 factorial divided by 2 factorial is giving me an answer of 360. Now the next one, the first letter is a consonant, the letter is a vowel, the third letter is a consonant, the fourth letter is a vowel, and so on alternately, and we've got to find the number of different ways we can do this. So we're going, you notice that there's 4 consonants, and vowels, there's 4 vowels as well, and we want consonant, vowel, consonant, vowel. So let's just write it like this: T, vowel, N, vowel, it's an A, Z, I, N, it's another consonant, vowel. Okay, so how many different ways can we arrange this? Well, we've got to have a consonant first. So let's look at the consonants. There's 4 of them, so 4 factorial, but you notice that 2 of them are repeats. So divide by 2 factorial. And then in between them, we've got 4 vowels. So we're going to arrange the 4 vowels in 4 factorial ways, but there are 3 repeats there, so we're going to divide that by 3 factorial. Now when we do this, I'm getting 48 different ways that they can be rearranged. 4 of 8 letters are selected. How many possible selections contain 1 N and 1 A? Exactly. Okay, so that means we've got 2. We've got N, we've got A, and then we've got option and an option. Now look at the different letters that we've got left. We've got T, Z, and I. Those are the only options left. And you can see that there are 2 places and 3 options. So this is an example of 3, choose 2. And 3 choose 2 is 6. Therefore, 6 ways. And if you didn't remember this bit here, you could always just go, all right, TZ, TI, or Z. Oh, wait, sorry, it's not 6 ways. 3 choose 2. Wake up. Sorry. It's just 3 ways, right? You could go That's what I was thinking as I was going through this. Hang on, there's not 6 ways. TZ and TI, and then the only other one is ZI. Those are the only 3 options there. Okay. All right, exactly 1n. Okay, how do you get exactly 1n? Well, you choose an n, and then the other letters that you've got are T, A, Z, I. Now, the way I thought about this is I decided, well, I could choose, for my other 3 letters, I could choose the A's, 3 A's. And there's only one way of doing that. Okay, you choose 1, 2, and 3. Now, I could have 2 A's, and that would leave me with what left over? Well, I'd have T, Z, and I, and hopefully you can see that there are 3 ways you can have 2 A's. And then I could have 1 A, and that would leave me with T, Z, I still left over, and I've got to choose 2 of them, right? 1 A and then 2 of them, but we've already found out that that would give us 3 ways, okay? Because it's 3, choose 2. And then no A's, and hopefully you can see if I've got no A's, I'm ignoring those ones there, that leaves me with the three letters. I have to choose all of those, so that would be 1 way. So altogether you can see that I've got 8 ways that I can have exactly 1n. Well, I hope this is helpful to you. I hope you're getting a little bit more confident with these. Take care, guys. See you next time.